In this video, we're going to look at topic 28, example 1, key features of f of x equals 2 raised to the x power. So this section, we're starting with exponential functions, and we're going to look at some of the features of those. Part A, what does the graph of f of x equal 2 raised to x power look like? And we have the chart already filled out. So I'm going to plot each of these points. We have negative 2 1/4, so that's going to be somewhere about here. We don't need these to be perfect. We're just looking for a fairly accurate representation of our graph. Negative 1 1/2, 0 1. So note that we have a y-intercept there. 1 2, 2 4, and 3 8. So if I was to connect these points, I might have something that looks like this. Try to draw this as accurate as we can. All right, that'll be good enough. So in the past, we've looked at linear functions where we had a straight line, something like y equals mx plus b. Here we're going to be looking at, again, exponential functions. So there's going to be a curve in our graph here. And if you look at point by point, moving from the left to the right, so if we were to go from, let's say, here to here, we have a slope of 1. But then from here to here, we have a slope of 2. And here to here, we have a slope of 4. So as we go further right, our slope seems to be increasing at a faster and faster rate. So this is really it. Just what does the graph of f of x equal 2 to the x look like? Again, note here that we have a y-intercept right there. All right, you're going to look at some of the key features. And something else you want to notice, this piece here, so this approaches 0. And I'll get into a little bit more on that in a second. So that line is approaching 0. It's getting really close to the x-axis. If you wanted to graph this using a graphing calculator, what you can do is when you go to y equals, you would type in 2 and then your exponent key and type in your variable. So you have 2 to the x. And if we were to hit graph on this, we get a graph that looks quite similar to what we have, which is good. The other thing you should keep in mind and that you want to get very familiar with is if you hit second and then the graph or the table key, this will bring you to the table that we graphed our points from. So rather than have to figure out each individual point by hand or working it out yourself, you can just use the graphing calculator to give you these points, and then you can graph them manually if that was required. So let's go back to the graph. All right, part B. What are the characteristics of the graph? And I already have everything written out here, so I'm just going to go through the explanations, and then that'll be it for this video. So the graph of f of x equals 2 raised to x power is continuous between and beyond the x value shown. So what that means, continuous, right? We have arrows going left and arrows going right. So since that arrow is continuing going left and continuing to go right, we have all the x values possible. So the domain, remember domains are your x values. So the domain is all real numbers. You can plug in any real number for x and you'll be able to plot that on a graph. It might be really high or really far to the right, close to infinity, but in practice you could plot any x value. This second statement, the function gets closer and closer to the x-axis but never quite reaches it. And if we go to our the table on the graphing calculator, our y values, if you notice here, get smaller, and smaller as we go, and then they start to get, exponentially small. So these are incredibly tiny numbers. So you get closer and closer to the x-axis, but you're never actually going to touch it or cross it. All right? So when a function approaches a line in this manner, the line is called an asymptote. All right, so you want to be familiar with this word here. And the asymptote of f is y equals 0, which y equals 0 is our x-axis, right? So that's the x-axis. The range is y is greater than 0, because all of our y values are going to be above the x-axis. So y's have to be greater than 0. They cannot be equal to 0 because it will not actually touch that x-axis. That's why, again, it's an asymptote, but the values will be greater than y. So your range are your y values. So domain are your x values, range are your y values. The main thing things that you want to take away from this is you want to be able to determine where the y-intercept is, which is pretty easy. It's just what is y when x is 0. You want to know whether the graph approaches 0, try to find what that asymptote would be. A lot of times there's going to be the x-intercept, and you want to make sure you're figuring out whether this graph is increasing or decreasing, moving left or right. So our x values, as they're going to the right, that's increasing, right? The x and the y are both increasing. Going to the left, the x and the y values are decreasing as you get closer to negative infinity. And that's it. Look at the try it problem and see if this kind of sinks in and makes sense to you.